The hidden ocean beneath the ice. The discovery of Antarctic subglacial lakes was not the result of a single expedition, but the gradual accumulation of evidence from multiple lines of investigation. Beginning in the late 20th century, scientists using radio echo sounding and ice-penetrating radar began to notice unusual reflections beneath parts of the Antarctic ice sheet. These reflections suggested the presence of smooth, flat surfaces beneath the ice, signals consistent with liquid water rather than solid rock or frozen sediment. Signals consistent with liquid water rather than solid rock or frozen sediment. Subsequent satellite measurements confirmed that these radar signals were not isolated anomalies. Instead, they marked the presence of an extensive network of lakes trapped between the base of the ice sheet and the bedrock below. Over time, researchers cataloged hundreds of these hidden bodies of water scattered across the Antarctic continent. The largest and most famous of these lakes is Lake Vostok, discovered beneath the Russian Vostok Station in East Antarctica. Radar imaging revealed a lake stretching approximately 250 kilometers in length and up to 50 kilometers in width, sealed beneath roughly 4 kilometers of ice. Because the ice above the lake acts as a barrier, isolating it from the atmosphere, Lake Vostok may have remained largely cut off from surface exchange for hundreds of thousands and possibly millions of years. Lake Vostok may have remained largely cut off from surface exchange for hundreds of thousands and possibly millions of years. Such isolation creates extraordinary environmental conditions. Temperatures within the lake remain near the freezing point of water, yet the immense pressure exerted by the overlying ice prevents the water from solidifying. In addition, geothermal heat from Earth's interior contributes to maintaining liquid water at the base of the ice sheet. For scientists studying extreme environments, these conditions are deeply intriguing. A body of water sealed beneath kilometers of ice, isolated from sunlight and atmospheric exchange, represents one of the most unusual aquatic environments on Earth. The existence of microbial life within such environments would demonstrate that ecosystems can persist under conditions once thought inhospitable to biology. Over the past 2 decades, researchers studying ice cores and subglacial samples have indeed detected microbial signatures within Antarctic subglacial environments, suggesting that microbial ecosystems may inhabit these hidden lakes and the sediments surrounding them. Studying ice cores and subglacial samples have indeed detected microbial signatures within Antarctic subglacial environments, suggesting these organisms do not rely on sunlight for energy. Instead, they appear to draw energy from chemical reactions involving minerals, dissolved gases, and compounds released through interactions between water and rock. This form of metabolism, known as chemosynthesis, is already well documented in Earth's deep ocean environments, particularly near hydrothermal vents, where microorganisms convert chemical gradients into biological energy. The presence of such organisms beneath Antarctica's ice sheet suggests that life can persist in environments that resemble those hypothesized for icy ocean worlds elsewhere in the solar system. That life can persist in environments that resemble those hypothesized for icy ocean worlds elsewhere in. They are living laboratories for understanding how life might survive in the dark oceans hidden beneath the frozen shells of distant planetary bodies. Did you enjoy this video? Let me know in the comments below. Like and subscribe for more.